Hello! Olá, pessoal do SouJava. Sejam bem-vindos a uma live aqui muito especial. E eu gostaria muito aqui de agradecer todo mundo que está aí online. Deixa eu dar uma olhada no chat para ver quem está aí. Mas quem tiver aí no chat pode falar aí. Nós vamos ter um convidado aqui internacional. Mas antes eu vou trazer meu amigo que ajudou a organizar tudo isso aqui, né? Que ele organizou, ajudou aqui a entrar em contato com o nosso palestrante e organizar tudo isso aqui com a gente, né? Então eu vou trazer aqui com vocês o Matheus. E aí, Matheus, deixa eu dar tem palmas aqui para nós. Calma aí, um esqueminha de palmas, cara.
É colocar aqueles efeitos.
Ó. Quer ver? Sai no barulhinho ou não?
Eu não tô vendo nada.
Peraí, e agora? E agora? Glória a Deus! E nós temos um outro, o outro SouJava líder aqui, né? O nosso Luiz. Luiz, eu vou trazer você aqui. A gente sei que a gente não combinou, mas eu vou trazer você aqui porque você é o cara que está sempre aqui ajudando a gente, ó. Grande Luiz, tudo bem?
Olá, tudo bem?
Tudo bem, tudo bem. Então, assim, eu gostaria muito assim de estar trazendo aí o nosso convidado, mas a gente já, para deixar claro, é um convidado internacional, então a gente vai ter que mudar para inglês aqui, tá ok? Mas se vocês estiverem aí no chat, quiserem perguntar, podem perguntar, até em português a gente tenta traduzir aqui, nós temos 3 aqui que podem tentar traduzir, aí vai ser bem legal. Bom, então, vamos fazer o seguinte, vamos chamar o nosso convidado. O que você acha, Matheus? Quer chamar ele? Quer fazer as honras?
Ok, let's start. Hey, Ondro, come here.
Oh, hold on. Let me add it here. Hello, Ondro. How are you doing?
Hello. I'm fine, thanks.
Let's chit-chat.
Where are you now?
Everybody's cheerful. I'm now in Europe, in Prague, Czechia. So it's about 9 in the evening. But I'm having a great time, especially with you, seeing you all so cheerful as usual in SouJava. So I'm happy to be here with you.
Yeah. Probably everyone on the chat will know how are you, but let me present to you. You are a Java champion that are very involved with Jakarta stuff. We are one that maintains Omnifish on the roll. So Omnifish is a kind of flavor of Glassfish. Am I right? Ondro can correct me. Feel free about that. And he also did a lot of contributions about Jakarta, especially in Jakarta Genocico. If you don't know, Ondro did a lot of contributions regarding Jakarta persistence under the Genocico, Jakarta NoSQL, Jakarta data, and so on. So, a lot of stuff, all right? But today we're going to talk about something that everyone is asking us. Am I right, Mateus? About migration, about those things, all right?
Yeah, let's modernize monoliths, right?
Yeah, let's do this. So before to get started, let me just to ramp up right here. So Mateus wants to say something before we get started.
I think I'm fine. I think we had a great opportunity to learn a lot and just enjoy the live, you know.
Oh, amazing! And you, Luis, do you understand? Share something?
Just want to say again how happy I am to have Ondro here with us. Thank you again for accepting the invitation. Thank you for sharing your knowledge to contribute to open source. And I want to share with Ondro that we know that he has lots of presentations, and we share with the community all of his topics. And this topic was the most voted. So thank you again, and I hope everyone enjoyed so much this conversation. Yes.
Yeah,
and I'll be on the background. If anyone wants to interact on the chat, I'll be here.
Yeah, I do the Luis words, my words. Okay, so thanks so much, Ondro, to be here. So just if you feel free to share your screen, you get started, and the stage is yours. Okay.
Okay, thank you very much, Max and Luis, and I'm happy to be here. I'll share my screen.
Great.
First, I will also complete the introduction from Max, and clarify what is Omnifish and what is Glassfish. So I'm now mostly doing. So the company name is Omnifish. That's the
Yeah.
company that I founded. I co-founded with other two people, and it's a play on words because we knew that we are going to work with Glassfish. We also are building another framework that's called Piranha, but predominantly we work with Glassfish and we provide support for it. And this year we also started providing support for all versions of Pyara community to bring them up to date for our customers before they are ready to migrate to Glassfish. But our primary contributions are to the Eclipse Glassfish project. And if you go there, you will see that we're very active there. Three quarters, I think, of all the contributions are done by our company. And the company is called Omnifish for two reasons. The fish is easy, yeah, that comes from Glassfish. And the Omni also comes from another project, and that comes from Omnifaces, which is a JSF library with probably some people know it still. It was very popular like 10, 15 years ago when JSF was very popular. And one of our co-founders is Aaron Times, and he is co-author and co-maintainer of this library. So that's how it came. Like Omni Faces is like the Omni thing for faces for JSF, and Omnifish is like the Omni for Glassfish. So we're like the steward of Glassfish, even though Glassfish is an Eclipse Foundation project, but the main driving force behind Glassfish is our company. So
Amazing. Thanks so much. Thanks for correcting me. And it's very interesting because sometimes I think that people did some little confusion. So thanks for clarifying those things for me. And my humbleness say that thanks so much. And I will glad every time that you correct me because I can learn much more.
yeah,
So
it can
let
get
me share.
confusing. Even a couple like 3 years after I left Payara, where I worked before, some people still thought that I worked there. So it's easy to confuse
Okay.
even with this new name. And we're pretty like we're not completely new company. It's already 3 or 4 years, but we're not very well known. So for many people, it's just first time when they hear about it, and when they hear about it, they think like it's like a fork of Glassfish. That's what happened with Payara. Payara became a fork of Glassfish too. But in this case, we worked on the very same Eclipse Glassfish in the Eclipse Foundation. And what we support for customers is primarily the Glassfish itself, as it's maintained and delivered in the Eclipse Foundation. Like in the same way as you have Tomcat, and Tomcat also has companies that support it. Some of the companies work on it. We are the main driver of the project. So we don't only support and provide consultancy, but we really add new features, make it more modern, make sure that it works on latest Java EE, and even implement things like I implemented together with Otavio and Arian Times the Jakarta persistence extension in JNoSQL, so that we can add it to Glassfish and have Jakarta data together with NoSQL and JPA there. So this is what we do with Glassfish.
Amazing. Thanks so much to bring those information right here. So right now, people, we can see that there's someone in the chat. There is Elder Neres, Gleiton Franco. There is a LG Real. I think that's Luis or Mateus as well. So everyone on the chat, feel free to send a question. Today we are talking about modernizing Java monolith. Java EE monolith is very, very interesting. And but feel free, if you can, let me just switch in Portuguese for someone that cannot understand it so well. Pessoal, no chat, fiquem à vontade de mandar a pergunta em português. A gente pode traduzir e fazer a pergunta novamente e tentar fazer essa dobradinha com o Ondro, ok? Vamos voltar para o inglês agora. Okay, I said my announcements, so I think that we got to start. We will be on the backstage. feel free to ask us for support. Am I right, Ondro? And I will put
Mhm.
your presentation on the screen right now, and feel free to get started. Okay.
Okay. Okay. So let me get started. We don't do any delay. This presentation is mostly about the path from monolith to microservices, something that few companies or pretty many companies started even 10 years ago or so when the microservices became a thing. Uh, but I haven't seen any company that is got rid of, or I rarely see companies that got rid of complete micro monoliths completely. From those that don't use monoliths, they probably didn't have monoliths in the beginning, and they're very young companies or have young projects. So they started with microservices, but most companies that I talk to people, I work with, they still have some parts of functionality in monolith, or even have all the functionality in the monolith and are just thinking about going to microservices. So if you're there just trying to plan how to get rid of monoliths and turn it into microservices, or if you're in the middle somewhere like on working already towards this, I want to share my experience where we work with our customers to do this, and what happened when we succeeded and when we had challenges, and what approach we chose, what worked for us. So what I'd like to talk about is how we came from monolith to something like microservices. But on the next slide, I will explain what that means. Uh, it's very complicated and almost impossible in reasonable time to really switch from a big monolith to microservice, and it's not economically worth it in many cases. So that's why I'm saying like we didn't get there completely. With most of our customers, we still have monoliths somewhere, but it's small one, and a lot of functionality is replaced by microservices. But it makes sense because a lot of the functionality that is still in the monolith is not changed very often. So it works, and if it works, it's not worth to touch it. Microservices are better for things that evolve faster, and you need to really touch them and improve. So that's what I want to explain. What we did, what worked really. So the best practices we adopted and worked. How we implemented the strangle fig pattern, which is a very like nice name for something that is pretty natural in the migrations. Um, and also some challenges that we faced and something that are not so shiny with microservices, but I'll explain. So first, let's start with the challenges. If you have monoliths, you probably are already aware of this. And I'm not talking about small monoliths, like monoliths or like simple applications to basically just do CRUD over a database for internal employees and used by, let's say, maximum 10 people. Not at the same time, but sometimes even just 10 people have access to these applications. I'm talking about monoliths which are really big, and a lot of them are exposed to public, so they are accessed by thousands or even more people, uh, then dozens of people at the same time. In reality, you rarely see applications where you have millions transactions per second. So I'm not talking about these. These are Netflix scale things, and they don't already have monoliths. They are already on hyperscaling microservices architecture. But many companies, banks, or just industries, insurance companies, I'm sure some of you work in some of these, have just applications that need to handle some transactions, quite big loads, but not that big that it would be really important to scale to the limit. Uh, so there are challenges already in scaling, but the big thing is when monolith needs to be handled by multiple teams. And I saw monoliths handled by around 10 or 15 teams, and that's when it really starts to be painful, because you don't have a single thing you cannot deploy individual components. You have a single thing to deploy. And when 15 teams need to deploy, and one of our customers was deploying just any time, they didn't have sprints like in Scrum. They just when the feature was ready, they deployed it. They used feature toggles, so it could be deployed and not used in production, later enabled. But they really wanted to deliver features when they were finished, or even half finished when they were disabled. And then it was pain because a lot of different teams wanted to deploy their new feature, and they had to synchronize. You cannot deploy in parallel. You have to only deploy one version of the product, and every team had to wait for the other team. And if there were tests, then all of the tests were running, even for those components that were not they were not touched. So there was really tight coupling between the components and also test suite. Everything was just together. Even if you touched one line of code, you had to deploy everything. You have to deploy everything with monolith. You have to run the whole test suite. In most cases, I know that it's possible to group or somehow shard test suite and somehow detect that if this component was changed, then run this test suite, but it's difficult to really do it correctly. So most teams, most projects don't do that. They just have a big test suite, and they run it against every release. Then when you are in production, you have trouble scaling, because if you need more performance, you have to multiply everything by two or three or four. You cannot just scale one service that is a bottleneck. You have to scale the whole monolith and create multiple instances of the monolith. So then it's not so complicated, but it costs money because you have to add resources, add memory for all of these instances, and it's pretty heavy. The other thing in monolith, which you might improve in microservices, that you are stuck with the framework. And if you started with Java EE, and if you started on things like WebLogic or WebSphere, you're out of luck, because they are very, very slowly innovating. They don't even support the latest Java version, and you cannot use the newer thing or switch to something else because everything is part of the same thing, and it only runs on the technology that it runs on. And the last thing is, like, I call it operational burden. This is everything. Like, when you do need to do something, it's always more complicated, slower, because like when you want to check out the source code, it's one big repository, so it takes time. Everything takes time. If you want to build, you need to build this whole thing. It's very rare that you can just build part of the monolith and just run it as a separate component. Most of the projects I saw, it was almost impossible. Or maybe it's split into 2 or 3 big components, but they are still big, and even if you run them separately. So these are most of the pains, and the biggest pains. Maybe there are more, but I think most people face them. And with microservices, on the other hand, we have something different. We can ship services separately, which means that whenever we change a component, we just deploy that component. We don't have to redeploy everything, so deployments are much faster. Test suites can only test this component. Then you can have like system tests and integration tests. You run them too, but only with components that you connect your component with. You don't have to run the whole test suite. So you only test that your component works with the other components that it's supposed to communicate with. You have technology flexibility, even though I would put limits to that, because in the past microservices were like, yeah, we can use Python for one service, Java for another service, that framework here, that framework there. But in reality, you don't want to do that, because if people need to switch teams, then suddenly they are the different framework, different technology. So people can learn just effectively use just a handful of things. So in reality, people's or projects or companies stick with Java, maybe JavaScript or Python, or Kotlin is good option because that's pretty natural for Java developers. But in reality, I really saw that companies stick with basically Java, and they are free to choose different frameworks. So for some services, it's better to use Quarkus. For some, it's better to use Spring Boot. Um, for some, just Jakarta EE implementation. So you can choose whatever works better. And but the technology is not so important. I think the most important thing is the team ownership, and that's because if the monolith grows and you have multiple teams that work with it, they step on other teams' toes. Basically, they depend on each other. That's one thing. What used to happen, or what practically happens, is that your team can suffer from mistakes done by other team. What I really hated when I couldn't start the monolith locally on my computer because some other team implemented their component in a way that it required some additional configuration to run locally, and they did it for themselves. They did it in test and production, but they didn't document it, and or even if they documented it, I had to do it on my own, and I didn't know how to do that. I tried to start a monolith after their change, and it didn't work. So you did nothing. Yesterday it worked. Now today you check out the new version from source code and it doesn't work, and that's really painful because you don't know how to fix it because it's somebody else's code on the other side of the monolith somewhere hidden on the distant place in a repository. If you own the thing and you're the only one that owns the thing, you know what to do to make it running, to test it and everything with it, and then you just ship it. And then you have to make sure that it works well with the other components of other teams. But you're not dependent on you're not blocked by other teams. That is very important for businesses because it speeds up the development. It also speeds up troubleshooting. If something happens in production and it happens in some component, immediately the incident inspectors or operation teams know which team to contact. With monolith, it's not so clear. They need to investigate what is the functionality and which team is responsible. And then there are other technological advantages, like with microservices, you can choose technology and deployment style that fits your needs, like cloud native, if you need to deploy to cloud, and things like that. It's possible also with monolith, but with monolith, you don't get so much advantage. With cloud nativeness or cloud native deployments, you can have scaling of the individual services and really fine tune your production usage of resources. And then basically the last thing is not an advantage, it's just basically a fact, I would say. Because if you think that you can implement microservices without messaging, that you use just blocking REST calls, you will end in microservice wall of mud. It will be basically just distributing monolith. Because then you really depend. If your service needs to call some other service via REST call, then you depend on the other service to be running, or you have to somehow mock it, and that's really complicated. If it's message driven, your service doesn't depend on anything, it just depends on the broker, which should be always there, sends a message or receives a message, and you can simulate reception of a message. You can just directly send a message or inject message into the message broker, and then your application sees it. And when your application produces a message, you can check it's producing the message broker, and that's it. You don't need anything running. And also in production, this is very important because in production, you can easily deploy without breaking things down. Only your component stops working, but the other components still can send messages to it. They don't care. when the other component that is being deployed is down for 30 seconds, it will just receive messages later after 30 seconds. So this is very important to keep deploying into production without downtime. So I'll try to group things to illustrate that it's not always shiny to get to microservices, but what you get is basically the better and easier is what I already told you. The stability, performance, resilience, deployment is easier, testing. What is different is team ownership. I already explained why it's important. What is also different is orchestration, which means here it's not so much positive because it's more complicated to deploy things into production. You have to think about how to maintain the configuration. It's no longer just in one repository. It will be probably in different repositories where you have configuration of how to deploy things into clouds. It's good practice to have infrastructure as a service, also versioned, so all the instructions to deploy, configuration. Then you also have to manage secrets because there will be a lot of different databases, a lot of different services, and you will have to have like user and passwords. Each service will have to have that, and you cannot just version it. That was also bad practice in monoliths, but in monoliths you had fewer services like this. With the distributed nature of microservices, you have to introduce something like a secure way to store and also retrieve credentials by services so that they know how to connect to databases, how to connect to message brokers, and things like that. So that's where it gets complicated. Another thing is that gets complicated is contracts, which means that different services need to work together well. If you have a monolith, the contract basically is compilation. So when your components compile together, they abide the static contract, and when you run tests, then they abide the dynamic contract in runtime. But if you have distributed components, they are probably in different repositories. It's not enough that they compile. It's just one component. You don't know if you send the message, if it has the format that the other component receives. So it's good to test these contracts, and for that you have to have some mechanism that is not in one repository or the other. It has to be a way how to verify that what you have in one repository matches what you have in another repository, and the versions match. So when you deploy them in production, the new component works with the other service, but also the old component needs to work with that. So yeah, these deployments of individual components can get a bit complicated. That's why sometimes people still deploy everything together during a maintenance window, even though there are individual components, because then you test everything well together. If it works together on the same test system, you just redeploy the same version in production, and you don't risk that you have for some time different versions of components that don't work well together. You just shut down everything and start up with the aligned versions of all the components that were properly tested. Yeah, so this is a complication, but it's up to you if you decide to really think about deployment and what's happening before deployment and after deployment. Sometimes in our case, we had to deploy like 3 or several components in specific order, because if we deploy them in a different order, the communication wouldn't work. Because we needed to change the contract, the format of the message that was being sent, and sometimes we had to deploy a new version of one component, of component A, then deploy component B, and then deploy again new version of component A. like basically deploy the same component in different versions just to handle the transition of this change, because we didn't want to have maintenance window. We didn't want to shut down everything and start up everything fresh new. Um, so when you want to have these um, almost negligible downtimes, you have to carefully plan your deployments. And then when it's all running, you need to think about maintenance. So yeah, I already talked about deployments, but also observability is a thing here, because you have data everywhere. It's distributed. Each service is logging uh, into its own file. Each service has its own database. There are message brokers. So it's important to monitor and introduce some tracing so that you can see how requests flow from one service to the other, how basically the communication is related. So when you have an error in one service, you can track which other service triggered this message and where it came from, to be able to simulate and fully understand what's happening in the system. In the monolith, everything was in one JVM, basically. You just needed to monitor what comes in and what comes out. Here, you can have multiple chain of services, and you have to really see where it goes into the system and where it goes out of the system, but also how it goes through the services between these 2 points. And then when you have different databases, which is a very common pattern that each service has its own database, you also need to synchronize data. So it's not enough to just create data in one service. Services need then to publish the data and publish every change of the data to the other services, so that everything is in sync. So let me start with where we want to get, basically. This is a schema of our ideal architecture with just microservices. Very shortly, I think it's pretty clear. We have a lot of microservices that have their own database, and they ideally communicate via message broker, so we can decouple them, and they can be deployed at any time without affecting other services. But then we also need to have web access or access from other system through HTTP, basically. So we need to have some gateway that then distributes processing to these services. But in reality, as I already mentioned, it's not that nice, because we cannot easily replace monolith. It's not economical, because if you think about it, to replace monolith with microservices, you have to basically refactor the whole monolith into microservices, and it takes time. If you have a really big monolith, it could be a 1 or 2 year project to rewrite everything, refactoring into microservices. What happens? During those 2 years, you still have to maintain the monolith. Sorry. Because that's the thing that is running in production. That's the thing that is bringing money. And you also need to update it, add new features to it, because business needs to evolve. And then it's hard to keep the new architecture, which is just in development stage, synchronized with all the changes in monolith. So you develop a new thing while still adding new features to the old thing. You have to port all those new features from monolith to the microservices project. And that's just what most companies don't want to do. The other thing is they don't want to invest into a 1 or 2 year project that just basically re-architects the same thing that they already had. It's just lost money from many managers, and they just sponsor 1 or 2 year project, and then they are basically at the same place the application is the same. It just behaves better, and there's less technical depth. But from business point of view, it doesn't bring any more money, maybe even less, because after 2 years of and not any new features, probably users stopped caring, and they have fewer customers. So the strategy is to use the strangle fig pattern, basically, which is as I said, really nice and but at the same time a strange name of a pattern, which is not even such a pattern. It's in short is just gradually replacing parts of the system by new parts. But the thing is, you don't replace, you don't refactor things inside monolith, but you copy the things into services, into microservices, and then gradually switch over to them. In fact, the old features can still stay in monolith. They would just be disabled, not used, because the microservice would take over. You can also remove those features if they are no longer used, and they will never be used, but they can stay there just in case, or because it's not worth to find all those places where you want to remove codes. So so this is how it goes then. You replace piece by piece, but as I said, in this case, you actually don't have to replace. You just copy in the microservice. You run things together. So monolith is serving things while the microservice is just there, doing nothing, ready to start working. And then you gradually shift the traffic to it. Either just with Big Bang, you just point all the traffic to the microservice, and monolith that's part that um, does the same thing as a new microservice will stop doing the thing, will be just there. The rest of the monolith will work as before, but just this one tiny piece of feature will be replaced by the microservice. But because we keep the old logic in the monolith, we can easily switch back to it. If we find out that the microservice doesn't do well its job, it contains bugs or anything, we can still revert the system to use the functionality in monolith and fix the thing in microservices. Another thing is what some teams I saw, that when they have critical loads, that they cannot just switch from monolith to microservices, because the logic was rewritten, and even though they tested everything, there might be some differences. They run the processing on both. They point or basically they yeah they point processing to both of them, so it's doubled. But then they compare the results. Monolith has its own database, and microservice has its own database, and after a while they compare whether the microservice has the same data, and if it has, it means the computation and processing is the same, and they can easily replace it. So they switch to microservices because they are confident that the microservice is doing the same thing as monolith, and they are sure that they can continue with the microservice. But before we can even start thinking about microservices, let me see.
Hey, Ondro.
Hey,
I got a question from the
yeah,
chat.
that's what I wanted to check if there are any questions.
Yeah,
Okay, go
I
on.
got a question from Vinicius Gema 13. He asking, which is the best approach to, let me add to chat right here. Yeah.
I think
I don't know if
yeah.
it, which is the best approach to put a feature in a microservice? Refactor the code in the monolith and then put it in a microservice, or just extract the microservice and it wherever it's needed. What do you recommend me?
Yeah, yeah. I think I understand you, and we had experience with various approaches, and depends on the situation. So first way is to first simple thing that we had on the big on one of the big projects was that all the new functionality went into microservices, provided that there was already microservice. So if there was no microservice for the functionality, then we had to choose. Either if it's just a small new feature, we kept it in monolith because it didn't make sense to introduce the whole new microservice and maintain it just for tiny little thing. But if it was a bigger thing, we introduced a whole new microservice and added the new feature. But also when it makes sense, because we were already building this new service and this new feature, sometimes we needed to bring over the functionality from monolith because it would be too complicated to have part of the feature in microservice and part of this feature in monolith and then synchronize that data. So it was easier to copy or take what is in monolith as a start, put it into microservice, and then build on top of this. So that's a different pattern, is to basically copy and create a new microservice, but with the intention to add new features to this. So we always delayed refactoring monoliths to microservices until the point when we really needed to do something with it and expected that in the near future we will be evolving it and adding new features to it. Another approach is to just not add functionality, but when there is some time, maybe every month, one piece of the functionality migrate from a monolith to some other microservice. Uh, it reduces technical debt, it decreases the monolith, and increases makes it easier to maintain the code in microservices. So you can do it. You can have technical tasks, and every sprint or every few months plan like 10% of our activity will be on this technical task of migrating this component or this functionality to microservice, and the rest will be business requirements and everything. Then you can plan. Is best to plan either, as I said before, that you have business requirement, add new feature, so you do it in the microservice and also bring over the other functionality that is related to it. So you just do it in one topic, both new features in the microservice and also together bring over something from monolith to have less of this in monolith and more in the microservice. Or you do completely two different topics, because you could have conflicts when you develop new features and also copy things from monolith to microservice. You could have two different activities on the microservice that could collide. So sometimes it's better to just develop, like when you have business requirements to change things in like area A, B, C. Then you pick area D, which you will not touch in the next 3 months, and just try in this area just to take things from from one monolith to microservice, uh, just to help you reduce the monolith and make it easier in the future to work with microservice. So yeah, just to summarize, you can copy code and create a microservice of it, but that's very rare because you don't get anything out of it, just technical benefits. Uh, what or you copy code from monolith, but also add new features when you need to add features. Or sometimes you just build new microservice for something completely new that hasn't been in monolith. So just everything, when you have something new that can be built on top of what is in monolith, you put it in microservice. You never put it in monolith. And then the approach when you basically copy functionality from monolith to microservice, sometimes you can do it in the way that you basically copy the code. And then when you have Java EE monolith, it's best to have also some Jakarta EE runtime, like maybe Quarkus or Go Glassfish, and just get the same code running with as little changes as possible, uh, just as microservice. Uh, Another approach is to rewrite it basically. So just keep the logic, but rewrite the code for a different framework. I saw teams migrating from Java EE to Spring Boot, where they had to rewrite a lot of things, a lot of wiring. Some of the logic, like it was just plain Java, they could copy it, but a lot of other stuff like REST services and everything, they rewrote to Spring. Uh, because this gives you an opportunity when you copy things from monolith to services, you can decide whether you want to just copy and stick with the same technology, or do the more work but do the transition to some other framework that fits you better or fits better the needs that you want to do with it in the future. So there are a lot of different scenarios you can do.
Okay.
And I
It's a
saw all of
trade.
them. I saw all of them in real world. So all of
It's
them are
a
valid.
trade-off game, all right. It's
Yes.
always a trade-off game. Okay, let's go back. Take it away.
Okay. So maybe the this part of my presentation like follows the question, because part of the answer is also in or how you modularize, or how you define which services in your monolith are logical units, and then you can either extract them as a microservice, or uh, combine these different logics into different microservices. So I think really it's really important, and that actually happened very often even before microservices were introduced, because when you have multiple teams working on the same monolith, you want to have different like areas of responsibilities. One team is handling payment, another one is handling inventory, other one customer service. Even if it's inside one monolith, in the monolith, you can usually the code is structured in a way that it's separate for different domains like this. And even if it's not, then people know, like these teams, when you have to introduce more people, you have to split them into multiple teams. They have some agreement that this area is ours, this other area is your team, and things like that. And then you naturally have to somehow group the functionality. And whether you do it in the code or you do it in the documentation or some diagrams, it doesn't matter so much. If you do it in the code, then it's easier to navigate through the code, and also a bit easier to port it to microservices. But even if you have just a logical representation as a chart, that's still something that helps you build a microservice, because then you need to document the microservices themselves, because then you have distributed architecture. And if you don't document how microservices are deployed together, how they work together, then you have real big problem, because then when something happens in production, you don't know how things actually work and which services should communicate to each other to another service. It's also a problem in testing and development, because then you don't know what are the dependencies or what you can impact. You can, if you, for example, develop in like let's say on this example, if you develop a payment service and introduce some requirements that I don't know, customers can pay only if they are from, I don't know, from Brazil, and if they are not from Brazil, they have to have some special permit, but the order service doesn't know about it. And if you deploy your payment service and the order service doesn't know about it, then the order service will send orders from Mexico, for example, without this special permit in the order, and it will be declined. And suddenly, if you do this in production, you will have a big problem. So it's good to have all the documentation of dependencies or the formats of messages or the contracts. So when you plan a change in, for example, payment service, you know that, okay, I will change this, but it will impact also order service because they will have problem if they don't adjust. So we have to let know the order service team that, hey, we're going to do this. You have to change this in your service to adapt. So it's important to document in the beginning to have a big picture of how things work together. And then when you split them into microservices, keep the documentation, at least high-level documentation of which services communicate with which ones. Best is to use infrastructure as a service. So you in code, you document how services are deployed and connected to each other. And then it's much easier than just trying to figure out what part of monolith to extract to a service. Because when you have a good boundary for a service, then you can also define a contract out of it. Because when you know that order service should call payment service, and it should send, probably now it's just a method call. You see this is an interface, for example. If you have an interface, it's a good start. And this interface has, I don't know, three methods. They have these arguments. So then you can turn them into messages, 3 types of messages, and they have this type of like these fields in maybe JSON. And then you can somehow test that order service follows the required format or expected format. Payment service accepts the format. And when you create a payment service, order service may still be in monolith, but it still needs to be compatible with the payment service if payment service now becomes a microservice. And then later you remove order service out of the monolith, but it will still need to follow the contract. So it's good to really have a good boundary for components in monolith, and then you turn them into microservices with a specified contract. Next. So when you plan migrating to microservices, I created this migration process, these 5 stages. It's very high level, just to give you an overview of what I would recommend to think about and how to progress. So first is where we are. So it's not really a step to do. That's the starting point. We are with monolith. We need to have some messaging. So almost in the beginning, you should start thinking about messaging. If you don't, as I said earlier, you might be tempted to expose some REST endpoints, and one service would call the other service. Yeah, it might seem simple. In reality, you still need something in between, some proxy at least. If you use Kubernetes, that maybe that solves a big part of it, because it exposes different services under some domain name, and then you can just point one service to the other by the domain name. But still, from architectural point of view, you end up with really something that is unmanageable. If you want to redeploy something in production, maybe the other service attempts to call REST endpoint or access REST endpoint of the service being deployed, and it will fail. So you have to think about retries and everything. It's impossible to avoid REST endpoints, but I would still think twice before introducing a REST endpoint between services. So in most cases, in the project that I worked on, the REST endpoints were basically public endpoints for other services external to the system, or for UI. So when browser page needed to access something, it accessed REST, and the JavaScript page accessed REST endpoints. But inside the system, everything what was possible to implement via messaging was message driven. It enables you to really work with the system in the way that it gives you the best advantage of microservices. Otherwise, you get not so many advantages at a very huge cost of distributed system that you have to maintain, and it's more complicated to troubleshoot, to monitor, and everything. So it's not really worth it. If you want to go that way, I would basically just split the monolith in 2 or 3 smaller monoliths, and you would probably be better off with this. So only if you really want to benefit from microservices, then you should think about messaging. And once you have these like infrastructural parts sorted out, you build a new service connected to messaging. You also need to think about the database and synchronizing databases. So the databases are usually synchronized by messages. So these are basically the 2 building blocks. Databases should be distributed, or not really distributed, but each service should have its own database. And then they are synchronized via messages. Yeah, there are cases where you really need to synchronize databases by some other means, by some scripts or something. So there are tools that do that. We use them, but they are very edge case when there's something when you need to do just once and it never repeats. So it's probably not worth to build Java code to send a message and everything. You just create some tool that migrates data from the one database to the other. But in most cases, and really in production, you want to synchronize everything with messages. And when you have the new service ready in point 4, or in point 3, it still doesn't do anything in production. So in point 4, you plan the traffic shift. You plan to point or configure other services to work with it and not work with the monolith. So if there is a method call in monolith, you change monolith to, instead of calling another component inside monolith, to send a message to Kafka, and the other component will suddenly start receiving it and will start working in production. So, and you can do it gradually. If you want, you can just send part of the traffic to the monolith, part of the traffic to the service, if it makes sense. Then you can compare how they behave, if the service, the microservice works well, if it performs well, anything. Or you can just do a big bang if it's not worth it, and you're pretty okay that or you're pretty sure that the new service will work very well. And you can always roll back. So you can always point the traffic back to the monolith or enable the functionality in the monolith. And later, an optional step, highly recommended, but you can do it much later after you introduce microservice, is to remove the old code from monolith. It's always good to remember. So when we didn't do it right away, we planned it as a project in next quarter or next year. So we really had it in plans. We just needed to find some space for removing stuff. The thing is, removing is really hard, because if you have a monolith where everything is like twisted together, then it's easy to create a new service and point things to the new service. But removing things means you try to remove one component and suddenly some things don't compile. Suddenly some tests fail because the tests were testing or relying on this component, even though it's not used in production. The tests were written in the way. So there's a lot of things you have to adjust just to remove the functionality. Sometimes it's not worth it, but it's always worth to consider doing it. I think I described this in detail already on the previous slide, so I'll skip it. Yeah.
We have another question from Kesha. Tell me about modular monolith. Few companies use it instead of microservices. Modular monolith, it's like a trend now, right? It became very popular for some developers? What do you think
Yeah,
about?
that's a good question. I don't have a really good answer for that because I don't have experience with modular monoliths, or actually not an experience since it became a bit pretty popular. In fact, I try to use like modularity on all of my projects, even when we started with a monolith, and sometimes we even ended up with a monolith because it wasn't necessary to split it into microservices. It's always good to have some modularity inside your monolith. Um, I heard about a project like Spring Monolith. They help with this. They even help in the way that they put some constraints. So if you don't follow some patterns, you basically connect modules that are not supposed to communicate together or things like that. During build, you get warnings or even errors, and then you're not allowed to do that, and you have to fix your code. Or you have means how to document how these modules work together. So I think there is a value in this, but you have to think this way always. It's just a lot of the time people were not educated and they created big monoliths, or they were under pressure, or they thought that in the future they will fix it, and then nobody fixed it, and they
Mhm.
just added more and more code, and
That's
it
true.
became really big ball of mud. But modularity should be a pattern followed anywhere, even in microservices. Inside the microservices, you can also have different modules, structure, code. That's important because in the future, maybe your microservice will grow big enough to so that you will have to split it into two or three. And if you keep modularity inside your microservice, it will be much easier to split it later.
Yeah, and do you think that would be a good approach to start to make a monolith modular instead of go directly to microservices in a modernization phase, or the developer should go
Ah,
all the way through the microservices?
Uh, yeah, so in theory, I would always recommend modularizing monoliths, but in practice, most of the monoliths that I work with, those that were really known as the monolith in the company, and even product owners and even like a cleaning lady, I would put it that way, knew what it means when somebody said the monolith. Those were things that really didn't nobody wanted to touch, and they were really complicated to modularize. So yeah, even though people would like to modularize them, it was so complicated and would be so much uh, lot of
Work.
effort to do it. So in reality, in most cases, just people like in these cases, the teams prefer to rewrite or port things into microservices rather than keeping the or turning the monolith better maintained as a modular monolith because it would require a lot of work. If
Yeah,
the
makes
monolith
sense.
is manageable, then it's good always good to refactor it first to more modularized, because if you do it properly and the monolith is not like huge and you don't have huge application with a lot of people accessing it, maybe it's enough. And it's still much simpler to have modularized monolith than have few microservices. If you have 3 or 4 microservices, it's manageable. If you have 10 microservices, it may become really a pain.
Yeah,
Uh, if you have just one monolith, one database, and it can handle the loads, why to split it into microservices?
yeah,
So
makes sense. Okay, thanks, Ondro. You may go on. You can go on.
yeah, so here I wanted to give you an example of what you could do with a monolith. Uh, I already mentioned what the teams I was working with they were doing. Some of them chose just a different runtime, still Jakarta EE or microprofile, to have a similar framework, or basically the same framework for their monolith and microservice. And there you can have embedded Glassfish or OpenLiberty. What is important there is that the implementation or the server is cloud native, I would say, in a way that you can easily run it in Docker, you can easily configure it, it doesn't consume a lot of resources. This is like a lightweight Jakarta EE server, basically, compared to traditional monoliths where everything is assembled together. I saw projects where they had like, even once I saw a project where they had hundreds VARs deployed to the same application server, which is kind of modular monolith because each VAR was a module itself. What was complicated there is that they didn't document how these modules work together, how they communicate. So when they tried to separate it, my first advice was try to split some of the modules and let's install another instance of application server and move some of the applications there, so that you don't have completely microservice, but you split the module into monolith into 2 or 3, make it easier to manage. But they didn't have good documentation how these services are connected and which services they can extract, and what are the dependencies, basically. When they tried to extract one application, they found out that it provides resources to another application, and everything is hard coded to localhost, for example, if it was a REST service or EJB. So they had to find out how to configure it, and then which all the EJBs are provided by one application to the other. So I think this is important when there was this question about modular monoliths, is to have some kind of procedure or framework that helps you with documentation of how these modules work together, what are the contracts between them, because then you can take them as components and install them as services or multiple smaller monoliths, but you know how to configure them together. And with runtimes like embedded Glassfish or OpenLiberty, or there are several others, Spire Micro, you can then take these smaller modules and run them as microservices with the same technology. Then there are newer runtimes like Quarkus or Halidon, which are semi-Jakarta EE. They provide some parts of Jakarta EE and microprofile. Basically, they decided just to strip off some things that are not widely used in microservices and rewrite everything or most of it and provide better experience, low resource usage. So if you want to try out something new, fresh, and still be more or less compatible with Jakarta EE and microprofile, these two, Quarkus and Halidon, are pretty good. There are something in between Spring Boot and an application server, because the top row is basically still something like a framework or a runtime that contains all of that you need. It's just designed to be very lightweight and load things for your application only if the application needs it. The second, Quarkus and Halidon, go with the approach that you need to assemble pieces of Quarkus and pieces of Halidon to build your application. So it's more like a Lego set, and you choose pieces and have to make sure that you have the correct pieces. One of the disadvantages of this approach is that when you suddenly in production realize that you would like to have some additional monitoring or something, and you forgot to edit to the application, you have to change the source code of your application, rebuild it, add this module, and then deploy, and then you have these things in production. While with things like Glassfish or Liberty, you can just enable them in production. They are not enabled by default, but if you enable them by some configuration property, they start, and you don't have to rebuild the application. And the third layer is Spring Boot Micronauts, which is similar to the second one, but different technology. So you not only have to assemble things so then just for your application, but you decide to go with different technology, which may be good if the technology is good. Spring Boot is very dominant and very popular, which means that you get a lot of information how to use it, how to build things, and also a lot of people who already know it. If you like to grow your team, but it's not compatible with your Java EE server. So you still have to maintain monolith. And I saw situations where we used Java EE Monolith, Spring Boot services, and then started with Quarkus because at the time Spring was not very good at AWS Lambda and serverless and native compilation. So we had three different frameworks, all of them Java, but you still had differences. And sometimes it was a bit painful to jump between different different services that were using different frameworks. I think we're close, or we probably don't have much time, and I've talked a lot about things in the previous slides. So I'll just, I don't know how much time do we have, Max?
Please don't go
Oh,
ahead.
Ondro, if you, I don't know how many time do you need? Because I think, can you hear me? I don't know if
Yes, yes, I can hear you.
yeah. Yeah, because actually, well, we used to spend 1 hour per presentation, but I think this kind of session is very interesting because a lot of developers are facing migration problems from monolith to microservice and so on. I don't know if you got a lot of talks, a lot of presentations, and feel free. I don't know. Do you need
Hmm?
how much? 20
Yeah,
minutes?
there are a few more slides, but yeah, I decided to talk about some other stuff, and we have questions. So
Yeah, yeah.
I think it's not important to go through everything. Yeah, so maybe I'll just briefly go through some things that are less important, and yeah, I'll try to make it short.
I
Well,
think
We
you
still
can
have some
speak
time.
freely because we have time. For us, it's a good time yet. But if
Okay.
it's not good for you, we
No,
may
it's fine for me. So I'll continue, and I hope it
yeah.
will be no more than additional 10 minutes or so. So
I
no
don't
see. I
problem.
see
get
some
bored.
comments. I see some. I saw some comments on the chat
Mhm.
about this stuff about migration, so on. So I think you this kind of topic is a very specific one that brings a lot of pain that people, the developers are facing today, because many companies
Mhm.
are modernizing those things, and Java is a language, is a technology that are coming through those years and keeping companies working so long. So I think it's a very interesting. Mel, I'm free to continue, but if you want to maybe switch to a kind of freely talk and questions and answer, it's up to you. Okay?
Well, it really depends. I'll check. I still there's a lot of slides. when I check it, but
But
yeah, I gave it at the
you,
conference. I
you,
gave this talk in 50 minutes, but here it seems like I talked too
man,
much, or there was just
you are a
questions.
VIP one down here in So Java. So we will have time to you if you want or if you need. For example, don't worry about that. If you want to split this one and then do those things in the next week or so on, feel free to that. You
Okay,
are a So
okay. So
Java friend. So
I'll just
no,
go on. Try to make it to the point now and not make it very very long. But if I have
okay,
some time, I'll try to use it.
feel free to that. We will be on the backstage. Okay.
Okay, so this slide is about front-end migration strategies. This is big topic per se. But
Ondro,
there's a yes.
I think if you want to
Full
put on a
size.
full window, feel free, okay? Or if you want to go on this way, feel free
Oh,
as well.
sorry. I thought I have it in
Yeah,
full
I got
window. It
that's it.
just somehow didn't refresh. I don't know why.
Yeah.
I need
Uh,
to
I think you need to
maybe
click on.
I need to
Yeah.
reshare, I guess, because I have it full screen on my side, but I don't see
Don't
it.
worry. We down here in Brazil also are good. Are good to discuss about code, but we don't understand anything about computer. So
The thing is that those things are crazy complicated.
Could be worse. Could be jeans. Jeans is also
okay,
very tricky.
Yeah,
it
it's
is.
most frustrating when there's so much to talk about, but the technology doesn't allow us to talk because the microphone
Yeah.
doesn't work or internet connection doesn't work or something.
We used to create technology to solve problems that doesn't exist yet. So you know what I mean?
Yeah, that's true.
Okay, go ahead, take it away, man.
Okay, so this is I just wanted to mention this topic of front end because it was quite interesting how I saw that it was solved in one of the projects that I was working on. It wasn't designed by me. I didn't really work with it, but when I attended a lot of conferences, a lot of Java conferences, obviously, most of them backend, I still saw people talking about microservices, talking about message driven and everything. But in the end, like when you have a UI and it's like part of the UI, like sometimes you can have a screen that is managed by one team, is one domain because maybe it's a checkout service, so there you have a checkout screen. But usually you have homepage and on the homepage you have components for different things and they come from different teams, different domains, and they ideally should come from different microservices, but the problem is how to assemble them together on one page. So there are different approaches to this, sophisticated or less sophisticated, but one thing that I rarely saw anything like that in conferences or talking about, and I saw it in a real project, uh, was the way how the components are generated, and that's basically the second point here is an approach to generate components because in UI when you have HTML and JavaScript based front ends, uh, everything is basically just resource. So browser loads HTML. HTML is a resource taken from a URL. The HTML contains references to JavaScript, images, and everything. Everything is just a resource. It's not compiled. So it can be stored in a database. And that was the approach that I saw. And it was quite amazing and worked pretty well. That resources were stored in the database in a monolith, but they were produced by microservices. So the microservices were the producer of these resources. Yeah, they were stored in the microservice repository. They were managed by the microservice. They were just sent as a Kafka message to Monolith. Monolith saw an update and it updated the resource. And every time you needed the resources or run the monolith to get the fresh resources, you had to like update them from the microservices, but Monolith still work on the old resources. If you wanted to run it locally and deploy just Monolith, it still kind of worked. There were problems if you like downloaded a newer version of Monolith and you had older version of database, so you had to download some later version of database. But that was kind of interesting way of using messages to distribute even the component that display in the UI. And then the monolith was just an aggregator of the components. But the real source of the components were the microservices. This if we compare to the first option with monolithic front end, and you basically just keep front-end at the monolith, and only the backend is in the microservices. But there you don't have the full advantage. You have microservices built as, or backend as microservices, but then you still have a big monolith that has all the front-end functionality and has to somehow work with these distributed backends. And that customer, we had teams that mixed front end and back end and even testers together. So it fitted very well because we could work on front end and back end together in a microservice, and then monolith just displayed the resources. So yeah, that is something that I always like to talk about as a good pattern that works very well for us. It's not so much related to Java or microservices per se, but it's specific to front ends. But I think it's a good pattern because it fits also the backend stuff. In the backend, when you have a database and microservices, one microservice is the owner of some data, it sends the copies of the data to other services that they know about the updates. But in this case, this is extended to the front end. Some microservice has the data, basically the components for front end, sends it via message to the monolith. The monolith just keeps the copy and serves it to the browser. So I don't know of any other way how to really get rid of monolith on front end because from like the nature of front end, you have a one page and you have to display the whole of the page. It's monolithic. The pages in web browser are monolithic because you have to have all the components there. So this is as close as we can get with microservices from what I saw. There may be some other approaches like when you load different components on the fly from different services, but the downside of that is then you have coupling. You have to have those services running. When you open the website or the page, you load the HTML, and if one JavaScript is loaded from REST endpoint from one service, another JavaScript or HTML is loaded from other service. They have to be running. But with this approach, the second approach here that I explained, we just need to have the monolith running, or it doesn't have to be monolith, the front end service running with all the components in its database. And the other services don't have to be running. They have to be just started or doing something else or redeployed. You don't impact the front end. There's just some delay. When the services start and they need to update the UI, then they send a message to the front end and you have fresh new UI. But even without the services running, the front-end service has all its needs in the database and can work. So I don't know I hope that I explained it clearly. It's better explained by some diagrams, which I don't have. But this is kind of interesting stuff in front-end. So for quickly through messaging, what I used very often it was Kafka, less often RabbitMQ, but it's also a good system. So here it's really up to you. If you are in cloud, I would also recommend the services in the cloud because you don't have to maintain them. The truth about Kafka and also RabbitMQ, they are services you have to maintain, and they are really critical. If they go down, a lot of your functionality may go down, even though your system should be resilient, and if microservices should just be able to run on their own. If they don't have access to the broker, they just try to resend the message after a while if the broker is down. Still, if you don't have the message broker up, everything gets delayed. Everything can degrade in performance. And to set up and maintain a good Kafka cluster and performant Kafka cluster is not really easy job. So I often saw it outsourced to companies that manage that for the project, for the company that was building the project. In clouds, you can leave it to the cloud provider. So if you use Azure Service Bus, for example, you just connect to Service Bus, and Microsoft is responsible to have it running 100% of the time. Difference between Kafka and RabbitMQ is basically just Kafka is good for fast processing when you don't care about losing some data, or if it's not, it doesn't have to be transactional. RabbitMQ is more for currency, so if you don't care so much about speed, but it's still fast, you need a little more guarantees, then RabbitMQ is better than Kafka. But both of them are very popular and very fast, so I'd recommend either one or the other, depending on the needs that you have. And then there are things what you do in production. So when you have Kubernetes and deploy services into Kubernetes, it's good to take advantage of the existing functionality in Kubernetes. If you deploy them in something else, there might be some similar functionality, maybe even using similar approaches. In Kubernetes, how it works is that you have a liveness probe, which means is basically liveness check whether the service is alive, and if it's not, it's possible to restart it automatically. Maybe when it restarts, it will work. That's on and off button. So in many cases, it just works when you restart it. Readiness probe is another important thing. It's big because it takes some time when a service restarts or redeploys, and during that time, it's good if there's no traffic coming in. And also, Kubernetes knows that it doesn't that if the service is not responding, it doesn't mean that it's unhealthy. It should be restarted. It means that it's just being started and it's just getting ready. So it's expected state, but we need to wait. And in that time, Kubernetes can either have some fallback mechanisms, so to reply with something just until the service is up, or wait for a little more time and block the request and respond with the request if there are incoming requests. Most of the time, I wouldn't rely on incoming requests. As I said, it should be messaging. So the readiness probe shouldn't be really important, but sometimes you really need to serve resources to front end or to expose something as a REST service to external services, and there it really makes sense. And for this, there are standard endpoints. Microprofile has support for some standard APIs. It allows you to define in your application some health check mechanisms. So if you implement them, for example, check on a database, then Kubernetes would automatically know if the application is up and healthy, or maybe there is slow database. If database doesn't respond in 1 second, then your application will report, no, I'm not healthy, I have a problem with the database. And then depending on how you have the setup automated restarts, it may restart the service, or it may be even a bit more clever and restart also the database for that service if it can figure out that the database is not healthy. Then what is also important to get set in production, which you don't have really problem with when you have monolith, is to support all these information that is out there in a distributed way. So services have typically lock into files. In monolith, you have just one log file with everything in there. With services, you have a lot of different files. If you scale services to multiple instances, each instance has its log file. So it's good to think about how to aggregate, how to store, gather all those logs, store them into some database. There are tools that gather and scrape the log files from different services and send them to a database. And there are tools that index them and allow you to search through them. Cloud providers typically have support for that, although they are not best at serving the data. So I would always recommend something on top of it. But for example, Amazon has a CloudWatch service, and all its services naturally automatically log into this CloudWatch service. So it's there. I don't recommend relying on it because the way how to get logs from that service is really painful. It's not really user friendly, but it's there. The data is there. If you connect some other service that can present the data more naturally, or download the data from there, and then allow you to search the data, then it's really a big win. Then what is important is to have correlation IDs. This is something that, again, we don't see in monoliths typically. But if some request triggers another request to another service and another request to another service, it may be messages, then it's even harder to track because they are asynchronous. So one service will receive a message from outside of the system, and it triggers another message for another internal component, another message to another internal component, and then you have a failure. You have a log message. Something went wrong. How do you find out the initial message from the outside of the system that triggered all these chain? Basically, the only reliable way is to introduce correlation IDs, and that means you add tiny identifier, or not really tiny. It's typically like a long hexadecimal string, which identifies the current thread, the current operation, but it also is transferred with the message to the other component. So the message contains the same ID. And when the other component receives the message, it knows that it's not a message coming from external system, but it's a message that was triggered by some other message from an external system, and it's related to the previous message. And then you see this correlation ID propagates through all those messages. And then if you also log the correlation ID, if you have correlation ID in the logs, then you can, and the logs are all in one place, you can search through that correlation ID. You can query the specific correlation ID, and then you will see all the log messages through all different services related to the same action, basically. And then you see the flow as if it was in monolith, because monolith logs everything in one file, and suddenly you will also see like one file, and it's like in monolith you have typically one thread that logs everything in one request. Here you have different microservices, but if you order them by time, these logs, and filter only those logs that are for the specific correlation ID, you get a nice log that describes what was happening from the time a message arrived to your system until, for example, an error in some service. And then part of it is also distributed tracing. This is not about logging, but this is about monitoring what's happening, and it's very similar. With tracing, you also have some kind of, maybe even the same correlation ID, but there you monitor how long request took, in which service took the longest to process some request before it delegated to another service, and what was actually happening through the whole request chain from the message that entered the system until something happens. So it's very important to have all these in place, to think about them when you introduce microservices, because if you don't, everything will work until it doesn't. And when it doesn't, then you will not have enough information to figure out what actually was happening, what caused the problem, because one problem in one microservice may be caused by completely different microservice, even 2 or 3 messages away. And if you don't see the whole chain, then it's really hard to figure out what was happening. I think I will skip this one. This is again about differences. I'd like to talk more about deployments. So I mentioned some of these, but these are the the advantages. You probably already have some clue, because you're thinking about getting rid of monoliths. So yes, with microservices, deployment gets faster because you deploy just one component. But beware, as I mentioned earlier, if some services depend on each other, you have to coordinate their deployments. Sometimes it's not just isolated deployments. Sometimes you really have to coordinate the order of different microservices, so be careful. But in general, it's much faster to deploy things, and very often they can be just isolated, so you don't have to care about other components or other teams deploying things. This is all very important because if even managers understand this, they understand that you can ship faster, because it's not only about developing a feature, but also get it into production. If you have a monolith where you compete with 10 other teams until you can really deploy your new feature, that may take days sometimes. If you have many other teams before you. If there's isolated deployments, you can just deploy your own service because it doesn't have to wait on anything. Testing also takes shorter because you only run tests for your test service and services it interacts with. And development, of course, very often you just need to run your service and test it in isolation. Then when you're done, maybe you run it against the monolith or other services, but you don't have to run the whole monolith every time. You need to work with the service and test it locally. Yeah, so this is about teamwork. Probably I mentioned some of it, and let me skip it because I don't want to go through all of this. This is important. What I want to mention also is, again, to prepare you also for the negative parts, not the bad parts, because this is more like natural. That's life, but you have to be ready for the complexity of microservices. And as we had the discussion earlier, sometimes it's not wise to really jump to microservices. Sometimes it's better to modularize the monolith or split it into 2 or 3 smaller monoliths that work well together, because you don't need that. You don't need that complexity, and you can still solve a lot of issues by just introducing modularity, improve documentation, how the modules work together, or even split into 2 or 3 smaller monoliths that you wouldn't call microservices, but there are services that are manageable. Because with microservices, you have all of these distributed processing, where you need to synchronize all the changes. When you change the database, you need to synchronize things via a message to another database. And when you refactor, for example, the codes, if you change things in your service, everything compiles. But if you send a different format or different data in the message, in the end, some other component will fail to work with the message because it will not have the same format. So you have to remember also to refactor the other component so that it accepts the same changes in the message. This is all of that with distributed nature, you have to keep things in synchronization. Data, versions of components, formats. So documentation is very important there. And then tests of components, how they work together. And planning of deployments if you plan to make some changes in formats. And then there are things that really can go wrong or are a pain. So sometimes you replace one pane from monoliths with a different pane in microservices. And one of the pains is the duplication of a lot of things. Since you have multiple services, each of them has its own repository. Each of them you have to maintain continuous integration pipelines, deployment charts, configuration in production, and everything. So it's good to, or it's wise to have manageable amount of services, not to introduce hundreds of services, but maybe just a few in the beginning, then grow it to maybe to dozens, but not more. I would say to than 20, 30 per company, even sometimes. I think from my experience, it was a good pattern to have rather one or two bigger microservices per team than have like 10 services per team. They were just too small and too complicated to maintain. So we sometimes merged services together, or at least kept them in the same repository, deployed them together, even if they were two different services running in, but they were managed as a single deployment unit to keep the complexity lower, to make it simpler for us to manage. Then, as I mentioned a couple of times, data synchronization is really critical, and it's very painful often when you don't have a message that really can distribute the change, or when you want to introduce something in a new service and you need to copy initial data from monoliths, then you have to have some kind of import mechanism, export and import mechanism, or create a job in monolith, just new job in monolith that will resend all the data as messages. So it may be complicated when you really need to synchronize data to a new service. And then other things I already mentioned a bit, observability and troubleshooting. It's important to know what's happening in production to be able to really solve issues when they happen. I talk about logs. So here, just to mention some tools that I used. Datadog is pretty good, or any other like monitoring tool that aggregates things. I think New Relic or some other stuff. But I think Datadog is very popular here out of those commercial options. It's also quite expensive, so it's like the highest level where we can get. Then there's ELK stack. Each letter means something else. I think E is Elasticsearch, L is Logstash, K is Kibana. So everything I think comes from the Elastic company, but all is on open source. And then there's CloudWatch from Amazon. So each three are different types of the tools. One is completely commercial, but it's very powerful, Datadog. The ELK stack is open source. There are other open source alternatives. This is just one example. And also CloudWatch is an example of something that is already in the cloud. May not be the best tool, but it's there. So it's good to explore what it gives to you, because it's there out of the box. But always I would consider something on top of this to really get the best experience and best access to the data. And then what helps is standards in monitoring, because then you can easily plug your services into these monitoring mechanisms. And recently, OpenTelemetry has been created or works as a very solid standard. Before there were some other attempts to standardize things, and OpenTelemetry is kind of like a merge of multiple initiatives into one, which is a good thing because we don't have you know how it goes with standards. You have 15 different things, and when you introduce a standard, you have suddenly 16 different things. So luckily here, OpenTelemetry seems like it's becoming really a standard supported by a lot of other technologies. And MicroProfile contains support for it. So MicroProfile implementations can be easily plugged into the tools that support OpenTelemetry standards. Okay, so this is probably too technical, and maybe one of the last thing is thing that a lot of people don't talk about, and that's costs. So the truth is, with introducing microservices, your cost of infrastructure will probably increase. Even though you can scale services now individually, so you don't have to scale monolith, like have a lot of instances of the whole monolith. When you have smaller services, each of them has to run on a separate virtual machine, typically. Each of them requires some RAM, and this costs something. So in the end, if you really want to just scale because you want to decrease your bill, it's not the best way to decrease your bill. Microservices are good if you really want to scale big and scale to something small. So you have big fluctuations. Then if you at some points of time you need like 100 instances of a microservice to scale really up because you expect high load, I don't know, before Christmas when everybody wants to do shopping and they go to visit your website or your services, then it makes sense because right after Christmas you can scale down to one and then it's cheaper. But if you want to like save the money and you still have the same loads all the year, so maybe it's better to have just a scaled monolith, even if it's scaling things that you don't need. In the end, it can be cheaper to just have a couple of instances of monolith. Also, all of these services and centralizing logging and monitoring and everything can be kind of expensive because there are some services, either you run them on your own and then you have to maintain them, or they are used as a software as a service or in the cloud. They are very often paid. So there's some extra cost to get something that you get out of Java EE server for free. But in distributed environment, you have to have something that aggregates all this information. And then when you have multiple instances of databases, it also increases costs. Even if the databases are free, you need to have resources to run them. And if you use databases that are not free, then you're very often out of luck because your company wouldn't like to pay for multiple more licenses of Oracle database than it needs to have. So I saw projects where they, for this reason, they have one shared database even for multiple microservices because they didn't want to pay for more licenses. I think I will skip these things because it only talks about more of what I already told you. So, well, I will end it up here probably, unless there are some other questions. I'd like to conclude that microservices are a good way, especially if you have really big monolith, to kind of tame it and then get a more manageable system. And as we talked about the trade-offs, if you have like monolith which isn't so big that you really see the pain, and I would say if the monolith is managed by one team, there's probably no reason to go to microservices. So if you need to manage it by two or more teams, then I think it's good to think about microservices so that each team can handle their own microservice, or one or two or three microservices, probably not more, but to reduce the dependency on monolith, because then the monolith becomes a shared resource and it always causes problems. But if it's not too big, maybe it's better to just split it into one service, one small monolith per team, and just keep it like that, or just modularize it and kind of synchronize the work of the teams. It really depends. But in the project I saw, there were some of the monoliths were really big, handled by multiple teams, and then it's really painful, and it decreases the velocity of deploying new features to production, because then sometimes it happens that the feature took 3 days to develop and another 3 days until it could be deployed, because there were some issues in deployment. Some other teams were deploying, things had to be rolled back. So it was really a mess. And at that time, it was much more easy to deploy a new feature in microservice, and we didn't have to wait for anything. It happened within a day, and it was done.
So amazing presentation. Thanks so much, Ondro. And well, I saw some comments on the chat. Vinicius have been doing some comments. For example, he are saying about he his Vinicius has gratitude for your presentation. So thanks, Ondro, for your presentation. It was amazing. We got Vinicius right here saying that monoliths are not bad. Yeah, that is are not. But I think as mentioned, as Ondro said, when we are broken those things, we are putting more complexity between those things. So it's very interesting. And
Now,
let's
I
see.
would say one thing: do not be afraid of microservices, but also do not be afraid of keeping monolith. So if monolith is doing a good
Yeah,
job, just maybe try to improve it, but
yeah,
also learn about what it how to do microservices properly, because maybe at some point you will need that. At some point you will not be able to manage the monolith, and it will make sense to split it into a couple of microservices. But at that time, you want to know how to do it properly, what is the actual cost, not only the benefits, but also the cost of introducing microservices, and how to do it in a way that you don't hit issues or hidden costs later, and then you would regret that you introduced microservices. So this is what was the main point of my talk, to get you ready to what you should expect when you decide to go to microservices, just to evaluate. Sometimes you would think like, yeah, it's too much hassle and monolith isn't in the end so much bad. Maybe we could improve it. Or, oh, this is interesting. I have to learn more about it. And when you learn more about it, maybe you will find out that it's not so much complicated and it perfectly fits what you need. You just need to get there, study it a bit more, learn the tools, try to play with them, introduce them. Some of the tools are good even for monolith, and then you will get ready to introduce microservices in a way that you will not regret.
yeah,
So,
yeah. Costs are very important. I saw many companies thinking about that. Of course, sometimes we saw, oh, I got a lot of microservices, but we need to understand that everything got costs, all right? And we need to pay at that. But thanks so much, Ondro. I got some. Oh, Vinicius also mentioned that thing. Just migrate to microservice if the application really needs. Yeah, we need to understand, as Ondro said in his presentation, we need to understand the whole picture of the solution and understand if it's benefit, we got benefits if you are broke on those things. And of course, the points that Ondro brings are very important. Costs is very important as well. We know that any company will not be able to rewrite those applications, all right? So you need to understand those things to keep those things work so fine. So I think that's it. Ondro, I will share your LinkedIn link in the chat to the people connect to you, to asking you to get more solutions, and also to get more clarifications. I think this 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 subject is a huge one, because we know that there are many situations and scenarios that you need to understand when we are migrating those things. For example, today I'm doing a migration from a special cloud account to another cloud account, and and right now my big issue is to keep those things working without failover, and migrating those things to another one. So there are many situations that you are mentioning right now in your presentation we are facing as well: logging, centralization, observability, so on. So those every kind of this point are very important. So thanks so much to bring those things to SouJava. I'm so happy to having you here. I'm waiting you in September, because you mentioned that you're talking about Jakarta. Am I right? And Jakarta, well, am I right?
Yeah,
So
there will be more information about Jakarta E12 because
yeah,
right now
yeah.
it's everything is like in like preparation for the final stage. They call it milestones, but no one knows really what is in each milestone, so we have to observe. But towards the end of the year, Jakarta E12 should be very close to release, and the plan
Yeah,
is to have it before Christmas. But yeah, we don't know how it goes because there are always things
I hope
to
to
be
get a
integrated together.
Christmas gift.
Yeah,
Right.
and even if it's not completely ready, I think in September I will have a good overview of what's coming.
Sure,
So it
sure.
still makes sense to have a talk to go through the new things in Jakarta. There are a lot of new things in Jakarta persistence, Jakarta data. So and maybe even NoSQL will become part of Jakarta E platform, although that's probably maybe for Jakarta E13.
Oh, great.
But yeah, a lot of things will unfold towards the
Yeah,
end of the year.
yeah, got it. I guess so. I think so much. I know, Mateus. Do you want to say something more to?
Mm, well, I just wanted to thank you, Andrew. It was a fantastic presentation. And if you can answer shortly, it's not an easy question, but
Okay, how much?
Oh,
if
Do we still
you,
have another hour?
I don't know if the Max wives will allow us.
yeah.
But if you would start migration tomorrow, would you try to start to migrate the easiest model or the painful one? So uh, would you try to migrate the easier model to a microservice or the hardest one?
Uh, if you want to start with, maybe like there's obviously no good answer to this,
Yeah,
but maybe I would consider first to try creating one service, one microservice that is the easiest component to like isolate from monolith, introduce it as a microservice, but not just because you want, but you should see some benefit in it. Maybe something that you change very frequently. When you change it very frequently, it's good to have it as a separate service because then you can just easily deploy it with,
yeah,
and the monolith can stay. Something that is managed by one team if you have multiple teams on the monolith. So that you have the benefits of it. You can quickly iterate on these components. You learn how to run it as a service, and you still don't have much complexity. If you have just one service, you can observe, learn from it, maybe introduce all of these things that I talk about, like distributed tracing and things like that, just to play with it, know how it works. But no big deal if it doesn't work for you because it's just one more service and you can still connect the pieces together. If you have like
yeah,
logs in
makes
different
sense.
two different places, you can still kind of investigate them easily. If you try to introduce 10 services at once without all these complex things, it would be a pain if something goes wrong.
Yeah, makes
So
total
I would start
sense.
with just one service, learn from there, and if you like it and if you see the benefits, then maybe you will immediately see some other five candidates of a new service. And then before doing that, I will introduce properly all the mechanisms to manage these services, to monitor them and everything, and carefully plan. And then you can introduce five more services and you're ready.
Okay, nice. Thanks for answering.
That's it. I think that we are end up our presentation today. It's about 2 hours of the presentation. It's a very long, but a lot of learns things that we got to ingest in our minds right now. Am I right? So I'd like to thank you again, Ondro, for this opportunity. Thank you for being here, and I hope to see you soon as you want. All right. And everyone in the chat, thanks so much to be here with us, sharing, asking, be part of the community because everything that's happening right here is for you guys. You are the the fuel for this, for food for this. If you want to keep those things work, send a message to us. Stay tuned in the Discord, SouJava Discord server to learn more about new stuffs that we are planning to this year's in the SouJava channel. Am I right, Mateus? And
Yeah,
um,
that's true.
and that's it. Thanks so much. Last words, Ondro, for today.
Um, just want to say thank you. Thank you for inviting me to be here. I spent a nice 2 hours with you. And I'm glad that some of you, stay with us until the very end. So it's nice, and I hope that I shared some knowledge that is really useful because I never know. Sometimes I think that I'm telling everybody just what they already know. So hopefully you learn from me. And yeah, if we have another session next time, let me know what you want to hear, what you would like to present or tell me like maybe don't come next time because it's not interesting.
All
Yeah, but
right.
yeah, it was my pleasure. Yeah, very,
Yeah,
I
yeah.
really enjoyed it.
We must thank you. And that's it. So thanks so much, everyone. See you next time. Bye
Thanks
bye.
everyone. See you.
Bye
Bye.
bye.